Probability of dependent and independent events. Independent versus dependent events. Events in which the probability of any one event occurring is unaffected by the occurrence or non-occurrence of any of the other events are called independent events. On the other hand, two events are dependent if the occurrence of one event does affect the occurrence of the other, like random selection without replacement. For the probability of the intersection of two independent events, if A and B are independent events in a sample space S, then the probability that both A and B occur is probability of A and B is equal to the probability of A intersection B is equal to the probability of A times the probability of B. Example number 1. A bag contains 4 blue, 3 white, and 5 red marbles. 2 marbles are drawn at random with replacement. Find the probability that the first marble is red, then the second is blue. So we have 4 plus 3 plus 5. We have a total of 12 marbles in a bag. And then we need to draw 2 marbles at random without, or rather with replacement. So this one is an example of independent events because as we replace the marble in the given bag, the number or the total number of marbles in a bag will not change. So now to find the probability that the first marble is red and the second is blue. So first, for the probability of having red, we have 5 red marbles in a bag. Over, there are 12 marbles in a bag. So we have 5 over 12. And then the next, after getting a red, we'll put back again our given red marble in a given bag. So the total number of marbles in a bag is still 12. And then we need to get a blue marble. So the probability of getting the blue marble, since in a bag we have 4 blue marbles, so we have 4 over the total number of given marbles in a bag. As we replace our given marble in a given bag, that would be equal to 1 over 3. And then for the probability of getting a red and then blue marble is equal to 5 over 12 times 1/3. This is equal to 5 over 36. Or 5 divided by 36 is equal to 0.14 or 14%. Example number 2. There are 2 red balls, 4 yellow balls, and 1 blue ball in a box. 2 balls are drawn randomly, one by one with replacement. Find the probabilities of the following events happening. First, 2 yellow balls are drawn. Next, the 2 balls drawn are not yellow. Only 1 yellow ball is drawn. At least 1 ball drawn is not yellow, and the 2 balls drawn are the same color. So we have 2 plus 4 plus 1. We have a total of 7 balls in a box. And then we need to draw randomly one by one with replacement of 2 given balls. So since we have the word with replacement, it means after we take 1 ball, we'll bring it back to the given box. So the total number of balls in a box will not be change or will not be affected. So this is an example again of independent events. Now let us answer this one by one. So for 2 yellow balls are drawn, so we'll have the first pick will have yellow, and then the next pick will have another yellow ball. So we have the probability of yellow and then yellow ball. So again, we have a total of 4 yellow balls over the total number of balls in the box, including the other colors. We have 7, so we have the probability of 4 over 7 times, since we have to take again the probability of having a yellow ball, that is still 4 over 7. So since the yellow ball will be put back again to our given box, so it is still equal to 4, and the total number of balls in the box is still 7. So therefore, we have 4 over 7 times 4 over 7 is equal to 16 over 49. Or 16 divided by 49 is equal to 0.33, or that is 33%. Next, the 2 balls are drawn. The 2 balls drawn are not yellow. So for that, we have the probability of getting not yellow and then another not yellow. So with that, so since we have a total of 4 yellow balls in a given box, the remaining balls are not yellow balls. So we have a total of 3 over the total number of balls again in a box is 7. So since we will have a replacement, the number of not yellow balls is still equal to 3, and the total number of balls is also equal to 7. So we have 3 over 7 times 3 over 7 is equal to 9 over 49. Or 9 divided by 49 is equal to 0.18 or 18%. Next, only 1 yellow ball is drawn. So we can have the probability of first getting yellow and then next is not yellow, or we have the probability of first getting yellow and then yellow. So since we have or, we use addition principle. So we have the probability of yellow, then not yellow, plus the probability of not yellow, then yellow ball. So with that, getting a yellow, we have 4 yellow balls over the total number of balls. So we have 4 over 7 times the number of balls that are not yellow. We have 3 over the total. So since in every pick of the ball, we'll have to replace it. We need to put it back in a given box. So the number of yellow balls will not be affected or will not be changed. The same with the total number of balls in a box. Plus, so getting first not yellow, so we have 3 over 7, and then the probability of getting a yellow, we have 4 over 7. Simplifying this, we have 12 over 49 plus 12 over 49, which is equal to 24 over 49. Or 24 divided by 49 is equal to 0.49 or 49%. And the next, at least 1 ball drawn is not yellow. So we can have first, if we have to pick the yellow and then not yellow, so getting the probability of getting yellow, then not yellow, or the probability of getting first the not yellow ball and then yellow, plus getting yellow and then yellow. So since we have or, we need to add again those probabilities. So we have the probability of yellow and not yellow, plus the probability of not yellow then yellow, plus the probability of yellow then yellow. So first, for our yellow again, there are 4 yellow balls over total number of balls in a box is 7 times 3 over 7, referring to the probability of getting not yellow balls, plus 3 over 7 for getting the probability of not yellow ball, times getting the yellow balls, the probability is 4 over 7, plus getting the probability of yellow balls, so still have 4 over 7 times 4 over 7. So again, the total number of balls in a box will not be affected since we have to replace the given ball. After we pick one ball in a box, we'll put it back in a given box to get another ball. So therefore, we have 4 over 7 times 3 over 7 plus 3 over 7 times 4 over 7 plus 4 over 7 times 4 over 7. This is equal to 12 over 49 plus 12 over 49 plus 16 over 49, or 40 over 49. Or 40 divided by 49 is equal to 0.82, or that is equal to 82%. Or another solution, the complement of at least one ball drawn is yellow is getting no yellow ball. So that is the complement of that. So we can have the probability of getting not yellow and then not yellow. So for getting not yellow ball, the probability is 3 over 7. Because we have 4 yellow balls in a box, the remaining balls are not yellow balls. So therefore, we have 3 over the total number of balls in a box, times probability of getting not yellow balls. Again, we have 3 over 7, or that is equal to 9 over 49. Now, getting its complement of at least one ball will have 1 minus the obtained probability, 9 over 49. So 1 minus 9 over 49 is equal to 40 over 49, which is the same as the answer a while ago. That is still equal to 0.82 or 82%. And then next, the 2 balls drawn are of the same color. So we only have either yellow balls or red balls because we only have one blue ball. So it will not happen that we have to get blue ball and then blue ball because there is only one blue ball in a box. So we have the probability of getting yellow, then yellow, plus the probability of getting red, then red. So we have plus because it's either you get yellow then yellow or red and red. So again, for the probability of getting a yellow, you have 4 over 7. Another yellow is 4 over 7. Since with replacement, nothing will happen with the total number of yellow balls in a box. The same thing with the total number of balls in a box. Plus, for the probability of getting red, we have 2 over 7 because there are 2 red balls in a box over 7 total number of balls in a box. Times 2 over 7 again for getting the probability of a red ball. Simplifying this, we'll have 16 over 49 plus 4 over 49, which is equal to 20 over 49. Or 20 divided by 49 is equal to 0.41 or 41%. Example number 3. From a group of 5 boys and 6 girls, a committee is to be formed consisting of 4 members. What is the probability that the committee will consist of 2 boys and 2 girls? So again, this one is an example of combination, a problem about combination. So we have to form a committee with 2 boys and 2 girls. And then we'll get the probability of that. So again, we have 5 boys, and then you have to select 2. So you have 5C2, or the combination of 5 taken 2 at a time. And then times, since we used and, this is multiplication. We have 6 girls, then we need to select 2 girls only. So you have 6C2, or that is combination of 6 taken 2 at a time, over, since we have a total of 5 plus 6 is 11, and then we have a total of 4 members for the committee. You have 11C4. That would be the total. That would be our denominator. 11C4, or the combination of 11 objects taken 4 at a time. So again, we have 5C2, or the combination of 5 taken 2, the number of ways that the boys can be represented. And then this one would be the number of ways that the girls can be represented. And the total, of course, would be the number of ways that the students can be represented. So we have the probability of getting 2 boys and 2 girls. So for the boys, we have combination of 5 taken 2 times, for the girls, combination of 6 taken 2 over combination of 11 taken 4. So for this 5C2, this is equal to 10. For 6C2, this is 15. And then 11C4 is 330. Simplifying this, we'll have 5 over 11. So the probability of having a committee of 2 boys and 2 girls will be 5 over 11, or 5 divided by 11 is equal to 0.45, or that is 45%. Now, what is the probability of 2 dependent events? The probability of an event B occurring given that an event A has already occurred in this symbol read as the probability of B given A. So thus, we have the probability of A and B is equal to the probability of A intersection B is equal to the probability of A times the probability of B following A. Example number 4. A bag contains 4 blue, 3 white, and 5 red marbles. 2 marbles are drawn at random without replacement. Find the probability that the first marble, this is marble, is red, and then the second is blue. So again, we have 4 plus 3 plus 5. We have a total of 12 red marbles. And we need to draw 2 marbles at random without replacement. So since without replacement, after we pick 1 marble, we're not going to return the given marble that we have taken. So meaning the total number of marbles in a bag will be changed. So this one, since we use the word without replacement, this is an example of dependent events. Meaning, there is something happened to the total number of marbles or objects. So let's find the probability that the first marble is red, then the second is blue. So first, for the probability of getting red, there are 5 red marbles over 12 total marbles. Then getting a blue. So since the first color is red, the number of blue marbles in a bag will not be changed because they are different colors. That is still 4. But with the total number of marbles in a bag, instead of using 12, we'll be using 11. It's because it is stated that without replacement. So after we take a red marble, the number of marbles there will be changed. So it will be deducted, it will become 11. So having the probability of red marble, then blue, will have 5 over 12 times 4 over 11. So that is equal to 20 over 32. Oh, sorry, that is 20 over 132. So 20 divided by 132, that is equal to 0.15 or 15%. or that is 5 over 33. So again, we have 20 over 132, or that is 5 over 33. Example number 5. 3 cards are chosen at random from a deck of 52 cards without replacement. So this is again dependent events. What is the probability of choosing a king, a queen, and an ace in order? So first, if we have to take first the king cards, we have 4 different king cards. So we have king of hearts, king of spades, king of clubs, and king of diamonds. So we have 4 over 52. Or that 4 over 52 can still be simplified as 1 over 13. And then after taking a king without replacement, the total number of cards in a deck becomes 51. Okay? And then we'll take the probability of having a queen after a king. So since we have taken king cards, so the number of queen cards will not be affected. So we still have 4 queen cards in a deck of cards because we have queen of hearts, queen of diamonds, queen of clubs, and queen of spades. But again, the total number of cards will be changed. It becomes 51 since we have already taken 1 king card. So we have 4 over 51. And then next, we'll take the probability of getting an ace card after the queen card. So again, we have 4 ace cards. We have 4 different suits. So ace of diamonds, ace of hearts, of spades, and of clubs. So we have 4, and then it will become over 50. After we have taken a queen from 51, it becomes 50. So we have 4 over 52, 4 over 51, and 4 over 50 as their probabilities. Now, to have the probability of getting a king, and then queen, and ace will be 4 over 52 times 4 over 51 times 4 over 50 is equal to 4 cubed over the, since we have mentioned the word order a while ago, this one is an example of permutation, or we can directly, since you have noticed, we have 52 times 51 times 50. So we can have 4 cubed, that is 64, over our given 52 times 51 times 50 is equal to 132,600. We're getting its permutation. We can have the permutation of 52 taken 3 at a time, that is still equal to 132,600. Or this is equal to 8 over 16,575. Or we have 8 divided by 16,575 is equal to 0.0005. Okay? Or we'll just take its fraction, that is 8 over 16,575.